Only today we will probably manage this. Monday we expect all of you to come here. Yeah. If I have one more point, so B. So its second point, I'll call it as x2, y2, z2. So what you get is another position vector of point B. So how do you express that? Vector OB is equals to vector P is equals to x2i plus y2j plus z2 theta. Okay, now you can get one more line, that is joining point A and point B, right? This and this, I can join these two, I'll get another line. How do you find the equation, vector form of this line? It's very easy. Triangle of addition. So now it's formed a triangle. So if I want this vector, this is like OB is like this. Other things should be opposite to this. That is, this is going opposite, fine. But this thing should come opposite. Means this is vector A, this is vector B. Vector B, this you want it in opposite direction. So minus A. So vector AB is equals to vector B minus vector A. That is vector OB minus vector OA. I can write vector B minus K. Okay. So what do you get vector B minus K? This minus this. That is x2 minus x1 I plus y2 minus y1 j, like terms we are combining. z2 minus z1 k. z2 minus z1 k. So now direction ratios of AB will be x2 minus x1, y2 minus y1, z2 minus z1. Okay. What is this magnitude of AB? That is, I can write like this, or I can write like this. These symbols will be confusing. Okay. So you need to understand these basic symbols. Magnitude I can write like this or like this. Okay. That is length of AB or distance between A and B. You already know Cartesian formula. So even by applying this magnitude, what do you get? Square root of I coefficient square plus like that. Square of this. Suppose if you have vector, any vector, say vector A is xi plus yj plus zk. Magnitude is what? Square root of magnitude of vector A is formula. No? Square root of x square plus y square plus z square. Same thing you will use here. And here it is equation is what? x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Right? You will get the number. Okay, these are direction ratios you can consider. These are direction ratios, coefficients. And then we want direction cosine sometimes. For direction cosines, what is the formula? Direction ratio divided by magnitude. If I want direction ratios, L equals to, here if x is there, x divided by its magnitude. Generally we call this as R also. So R. M is y by R. N is z by R. How it comes this one? Cos. What is this thing? Cos, no? Cos of, if you take cos, what is cos? Adjacent side x divided by hypotenuse x by r. So that's what we will get these things. Okay. This is what actually we have learned yesterday, and then we learned one relation, that is L square plus m square plus n square equals to 1. Based on that, you have done some problems. Now you see, for a line, you know how to find direction ratios, direction cosines, and magnitude, you know. But how to find equation of the line? That's what we learned today. So I will erase this. And this is a 5 marks question. Finding the equation of a line in 3D. So in 2D, you had a different forms, like 2-point form, point slope form, insert form, 1 point slope and insert form, like that. Many forms you had today. If you remember straight line, what you have learned last year, you had many forms, 10 forms were there. But here there are only 2 forms. So how does the 2 forms comes, you need to understand. Think of any line in 3D. For example, Okay, this chart, this is straight line in 3D. Okay, right? So, how the line will be uniquely determined in 3D? If I decide 2 points, okay, suppose if I think of a point, fan point and that light point. So, you can draw only one line, na? Joining that light point and fan point, you can draw only one line, yes or no? 2 points uniquely will determine your line in 3D. That holds good. Even in 2D also same. If you have 2 points, you can join in those two things, you can draw only one line. So that holds good even in 3D. Okay? That is one form, 2-point form. Another is, you had in 2D a slope and a point form. You know slope of the line and you know one point. That also you need to determine. Same thing applies even in 3D. You know one point. Okay? If you take any one point, okay? Take for example, any one point here. If I consider one point, how many lines I can draw? Here, look at this point. Look at here, there is a point. Joining this, many lines you can draw. Now you can see this as one line, this as one line, this as one line. So all the lines are going through that point. Yes or no? Yes or no? Through one point we can have infinite lines. Yes or no? Through 2D also same, 3D also same. If I have a point, I can draw infinite lines passing through this. Yes or no? So one point cannot uniquely determine the line. So can somebody tell what is the other property which makes it unique? In 2D it is slope. Here we call it as direction. Direction is nothing but slope. So if you know direction of the line at one point, any one point on the line, then that is also your line is unique. Okay? So these are the 2 forms that you will be learning. First we will learn equation of the line. Write down this heading. They will give derive the equation of the line. How they give? Derive the equation of the line. Page number 468. Today I want to do both the derivations. Derive, write down like example question only. Derive equation of a line. Derive equation of a line through a given point. Through a given point and parallel to a given vector B and parallel to a given vector B. So you want one line parallel to something, it means you have fixed the direction. Yes or no? Yes or no? You want equation of the line parallel to some vector. It means parallel to two vectors which are parallel have the same direction. Yes or no? The direction ratios are same. So when I say that my line is parallel to some vector, it means you have fixed the direction. If I say I want something parallel to this tube light, okay, means what? All the lines horizontally going parallel to that. Yes or no? Now you also decide one more point and a given point means you will get only one line. So how do you find the equation of that line? This is the thing. In the textbook they will give lot of theory in the form of it like a paragraph, but we write point by point. I will try to avoid lot of words. We will put everything using symbols. And then this thing you have derived in 2 forms. One vector form, another Cartesian form. So they might have sometimes put this equation in vector form. Then you have to give vector form of the equation. If they ask Cartesian form, you have to give Cartesian form. Okay? So whatever is given, you need to put it in the form of a diagram first. So diagram you have to draw very nicely. 3D diagram. 3D always this is how you will follow. This is x axis. y-axis. This is z-axis. So this is the coordinate system. Now here they are telling given vector b. So there is some vector b here. Vector b. Vector b like this. There is one like vector b that is given. And then one point is given. Through a given point, a point is given. Let's take point here. So this is point A, let's call it. So this point is given means you know its position vector OA. So what is called this one? This is O. So here let us call this as x1, y1. Generally, okay, I will not write here. I will write it below. It will be clumsy. Let us A only. We will write below A. So A can be written as in Cartesian form it is x1, y1, z1. This is a position vector A. And vector is OA can be called as A. It is x1 I plus y1 j plus z1 j. Now vector B. This is a given vector. So here, please remember, sometimes they use letters A, B, C. But if you observe when they use the letters A, B, C is whenever you want to represent direction of the line. Direction of the line. Okay, here you want a line parallel to some line. Means there you are trying to find out direction basically. At that time, generally you use letter A, B, C here. It's a convention. You could have used anything. But here textbook uses A. A means you know. Means some value we will have. A I plus B, so Bj plus Ck. These two are given. Point A is given, vector B is given. Now you need to find out what you need to find is the equation of a line passing through this and parallel to this. So now you should draw a line such that passing through this and parallel to this. So you can draw a line like this. This is parallel to this and passing through this. So what is that equation? This is what you have to find. Okay. This is parallel. I will put it more down so that it is parallel. These two are parallel. Now you need to find out the equation of this line. How do you find the equation of that line? What does it mean? Basically, you need to give general point here P. That we call it as P, O P. O to P. This P can be anywhere. It need not be here. It can be here, anywhere. That represents general point. So that's why point P in Cartesian form X, Y, Z. But OP, okay, this thing I told you, OP is considered as R. I don't know why, but textbook uses this convention. We call it as vector R. That is xi plus yj plus zj. So this is what you need to find OP. Okay? Now for that, OP is given. Okay? We'll do simple. So, triangle law of addition. You can see here. This is what is given. What you need to find. Okay? Maybe I could have written this one here. Let me write this here. So that our derivation part will do that. So here we will write OP is equals to R equals to xi plus yj plus zk. So this is what you have to find. Anybody any idea? It's only these derivations are so simple actually. Once you understand this, you have to draw this diagram, represent this. Okay? You don't have to write all the sentences. If you write, it's good. I'm not saying that you should not. If you write, it's good. What you say is OA is the position vector of the point A. B is the direction. The vector B is the line. This is the given vector. Yeah. The parallel to a given vector. Okay. You need to find. Okay. B is basically a line. Okay, which has the direction ratios A, B, C. and P. P is a point on the line, general point on the line. Okay, and it's okay. I did not give the coordinates of P. Let me write the coordinates of P also. First, P coordinates are x, y, z. Then OP is R is xi plus yj plus z3. So you see, I am writing both the things. This is Cartesian form, and this is vector form. And this one, this is given. So they will give it the vector form only. Only directions you wanted. If you want direction ratios of this, that is A, B, C. So that much. This is given. This is what you need to find. To find this, you just use triangular addition. What you do here, now you got a triangle here. Now you call this, you call it as say AB. Now there are two equations that you will write. First thing is, this is parallel to this. Yes or no? If two vectors are parallel, you can express that as, you can write vector AB is equals to lambda times vector B, means some scalar multiple of this. What it means is, vector B so much is there, and you wanted AP only. So what you do? So you multiply this with some scalar, half it. If suppose if you wanted half of it, 1 by 2 multiply, that is lambda. You will get vector B. Because direction is there already here. You wanted magnitude. So that magnitude, whatever magnitude that you wanted, if you multiply with that scalar, you will get that for the direction. So that is one equation. Then the second equation, consider triangle OAP. In triangle OAP, okay, I can write AP is equals to vector AP is equals to, tell me what is vector AP? Triangle of addition you have to write. OP minus OA. This is the opposite you wanted. Yes or no? Because this is going like this, other things will be opposite. So you remember this, if in case whenever you have a doubt, think of this. Mysore to Bangalore, Bangalore to Chennai. See, Mysore to Bangalore, Bangalore to Chennai. Okay? Now, what is it basically? You have gone to Mysore to Chennai? Yes or no? So see the direction of these things. This is going like this is going like this. Here, opposite. Okay? Now I'll change my point here. So I wanted like Bangalore. Now I'm going Bangalore to Chennai. Chennai to Mysore. What does it mean? I wanted Bangalore to Mysore. This thing is it's Bangalore to Mysore, huh? B to M. What is B to M? This is fine, but this is, it should come opposite. Yes or no? So BC, vector BC minus vector CM, because opposite you have to go. If you are going like this. No, it's actually not. You have to come like this. Yeah, correct. So you wanted BM, you wanted like this. Then at that time, what you do? You have to go like this, BC, and then opposite of this, CM.
So minus MC.
Minus
MC. Right.
Minus MC.
Greater than or
Oh, yeah, correct. Minus MC. Sorry, correct. CM if I write, then, yeah, see here. If I write CM, what does it mean? Starting point and ending point. Suppose if I have M to C, then I should write MC. If I write CM, then you don't need to put minus here. See, MC is like this. CM means like this. That's property. Okay, so this is triangular function. Basically, whenever you take a triangle, so suppose if I want this one, other two things must be opposite to this. Like this it should come. Okay? So here that's what you wanted. You wanted AP. So you wanted these two things opposite. Here you know OA. That's why. So vector AC is vector OP AP minus. So this thing actually you wanted opposite. That's why minus OA. Minus OA. So vector AP now you know this one. That is this equation one you can call it. So from here you can substitute this one. That is lambda times vector B. What is vector OP? That we are calling it as R. Vector R. We can call this as vector R. If you want, I can show this here. This is vector A. So this vector R, this vector A. So just substitute that. Vector R minus vector OA is vector A. Okay. Now what you wanted is, what you need to find? You need to find this one, general point on the line. That is vector R. So keep R one side, send this to this side. What happens? And I'll write like this. Vector R, I'll write one side. And this one comes this side. That is vector A plus lambda times vector B. That's it. This is your equation of the line in vector form. Okay? So this is your vector equation of the line. The equation of line in vector form. Now can we do Cartesian form? This is vector form. I'll use this space for doing Cartesian form. So for Cartesian form, Cartesian form is basically applying your vector algebra operations here, nothing else. So for everything you know, its component forms. Vector R, what is it? That is xi. You start with this only, you write this. You always derive Cartesian form from vector form. So vector form is this. Now you just have to substitute component form of these vectors. R is xi plus yk plus zk. A is x1i plus y1j plus z1k plus lambda times, so you write in the horizontal line. Here I don't have space, I'll write it here, but you write it horizontally. Lambda times vector B, that is ai plus bj plus ck. So now, here you can take I common, you will get x1 plus what you wanted is this one right here. X1 here. It's minus, huh? R equals to, sorry, R equals to something I made a mistake here. Lambda, correct. That's fine. This is all. If you want to use brackets, we can use brackets. This is one, this is one, this one. Like this. Now you see, next step. Let me get more space so that I can write in one line. So I will write this xi plus yk plus zk is equals to. Here I can common, right? Between these two things, I can write x1 plus a times lambda. This is a times lambda. Here x1 for I is common. So I plus. Are you understanding this step? See, here this x1 y1 z1. Here lambda a I. So if you take I common, what do you get here? X1 from this and from this A times lambda, or lambda into A or A times lambda, both are same. And here Y1 plus B times lambda for J. Y1 plus B times lambda times J. So even though I am putting one line, I am not getting. Okay, next Z1 lambda times C. Z1 plus C times lambda is equals to K. Okay. Now you see. Now what you have to do? Equality of two vectors. So this and this are equal. They are same. Means I coefficient here and I coefficient here must be equal. Y coefficient here, that is J. J coefficient here. J coefficient, this is J, okay? Y. So that must be equals to J coefficient here, J cap coefficient. Here, K cap coefficient Z, that must be equals to this one, right? These things are common. I, J, J, K. So its coefficients also must be equal. That is, X equals to X1 plus A lambda. That is one equation. Then Y is equals to Y1 plus B lambda. Then Z is equals to Z1 plus C lambda. Can you write this please? Yes? Yes or no? Equality of two vectors. Okay? Now, next, last, final step. So this plus x1 is under this side. What happens? X minus x1 is equals to A lambda. A also you can send this side. What happens? Here it is multiplying. If it comes here, divides. Equals to lambda. Is it okay? Here, lambda and keeping one side, all of the things other side. Plus x1 comes here, x minus x1. Because here it is doing addition. But A is multiplying. If it comes this side, divides. Then here, y minus y1 divided by b is equals to lambda. Here, z minus z1 divided by c is equals to lambda. Right? I am just keeping lambda here for all the equations, sending other things here. Now you see, all these values are equal to some constant lambda. So I can replace all of this like this. X minus x1 by A equals to y minus y1 by B equals to z minus z1 by C. So this will be your equation of the line in Cartesian form. What does it represent? Lambda represents here is for every value of, for specific value, lambda is some constant. You can keep on changing that value. If you keep on changing that value, this point becomes maybe this here now. If you change the lambda, you might get here like that. By changing lambda value, you will get all the points in this equation. That's what it means. Okay, you need to understand what is this lambda. So this you can consider it as Cartesian form. So the advantage of Cartesian vector form here is, you see in Cartesian form the equation is so long, but in vector form the equation is simple. Okay, that's the advantage of studying vector form. So in vector form, what I would suggest, you remember things in vector form. Then from this you can easily get these things. Here you wanted, you see one step only you can get all of this. You wanted lambda. What is lambda? R minus A divided by B. And here you take only coefficients. All coefficients are x minus, here x1, here direction A. I said that for direction ratios you will use ADC. So x minus x1 by A, y minus y1 by B, z minus z1 by C. Sometimes they ask only one form. If they ask just derive the vector form, write up to here, it's enough. Okay? If they don't say anything, you write both the things. Sometimes they say just give the vector form of the equation. Then for this half is enough, this much is enough. If they ask for Cartesian form, we need to do this one. Is it clear? Any step you want me to repeat? All of you understood? The next one is how much time do you got? 20 minutes. Okay, we can finish the next one. So have you written? Everybody, can I erase this? So slowly I'll erase from here this side. I'll keep that for some more time. The next one is equation of the line. You write the equation of the line passing through two given points. Passing through two given points. Here one point and one direction is given, but here the right equation of a line passing through two given points. So here 2 points are given for you. That is the thing. From that we need to derive the equation of the line. So I probably start a little bit this side. First reference frame x, y, z axis. Sorry, x, y. Now 2 points are given. So your book has taken 1 point this side and another point this side. Okay. Wherever you take, doesn't matter. Here, or here. So I'll take like this only, so that when you are referring to the book, you should get similar thing. So point A here, point B here. 2 are given. So what does it mean? Position vector is given. That is OA is given. This is O origin. OB is given. OB is given. Please observe diagram. While I am writing the diagram, please observe. Okay, then we can write. Okay, I'll give time. 20 minutes is there. I'll finish in 10 maximum 15 minutes. Last 15 minutes we can write. Okay, because this diagram is very important. Okay, the sequence that you draw, you don't have to remember. If you remember the problem, from that only you get. So everything first you start. You draw the reference frame. Then 2 points are given. You can take 2 points anywhere. I could have taken here and here, no problem. Here and here. Okay, book has taken 1 here, 1 here. Okay, let us take like that. So if you take OA, then O to A. This is this vector. O to B, direction is important. O to B. So OA you call it as what? Vector A. OB you call it as what? Vector B. Okay. What you need is, you need to find the equation of the line passing through AB. Means you have to join A and B. Draw a line passing such that it passes through A and B. Okay? You need, this is the line. Okay? Oh, in the previous thing, I missed one very important point which okay? You should mention that line, given line is parallel to B. I did not write anywhere. Can you please write down? Now I am realizing. So here, below the diagram, I have written A and P and B I have written. One more thing that is given there is vector B is parallel to your line L. Please write that one. Because what is given is the information that we did not represent, that point you should put. Vector B is parallel to L, or you can say L is parallel to the line that you need. L is parallel to vector B, like this also you can mention. That's very important, okay? That's how you look at it. Okay. Sorry, now I'm recollecting that. Okay. Yeah. Now in this, I think whatever is given we have mentioned. Nothing else. There they have given 1 point and 1 vector, and also they mentioned that vector is parallel to the line. The required line is parallel to that vector, given vector B. Here they are not mentioning that. But is it possible for you to find out direction of the vector given 2 points? Yes or no? If you know 2 points, now you know this point, you know this point. Can't you find the direction of this? We can find, right? That is b minus a. x2 minus x1, y2 minus y1, z2 minus z1. So you got the directions, right? And then you take any one point. 2 points you have here. You can take any one point. Now you know 1 point, you know direction ratios. You will get the equation of the line. That's the concept behind that. But let us write step by step here. So please observe, don't write. So first thing I will write vector OA. Vector OA. So given point. So it's point 1. So I will call it as x1, x1 I, y1 j, z1 k. So this thing in A how do you write? x1 Cartesian form. In Cartesian form it is x1, y1, z1. Here B, it is x2, y2, z2. This Cartesian form. Vector form OP. So this is also known as vector A. This is vector B. OB. This is x2i plus y2j plus z2k. So this is given. So you have expressed diagram and also using symbols. Now what you need to find? Equation means you need to find any point on this, right? General point. So that is you need to find the OP. What is OP? So P is general point x, y, z. R equals to OP is equals to xi plus yj plus zk. This much you should write using symbols and diagram. Now your logic will come. How do you find this? P or R. Okay? How do you find that? So what you do? You consider first of all, you know 2 points. A and B are fixed. Yes or no? P is somewhere in between this. What does it mean? Its magnitude is changing. Direction is same. Yes or no? First equation you can write vector AP is equals to lambda times vector AB. It's a part of this. The AB, you know, these 2 points are fixed. Yes or no? Now you wanted AP. AP is some part of AB. That is lambda. If you make, suppose if P is a center, it is half of AB. So lambda is half. Suppose P is somewhere here, so 1/3. So lambda is 1/3 of AB. Here, that value represented using a lambda. Okay? So you will get all points P. Right? So that is one equation. Okay, next AP can write. Okay, next one more equation we will write. So I can also write. Now you take OAB. Let's take OAB. Triangle. Call this as equation 1. Next equation in triangle OAB. I'm considering this. Okay. In OAB, I can write vector AB is equals to. So this one, okay, here. AB also is like this, AB also is like this. This vector equals to this vector minus this vector. Whenever this minus this, remember like this. This minus this. Okay? Same thing is happening for OA also here. This minus this. What is this O? It is 0. So that's why you get x1 minus 0, y1 minus 0, z1 minus 0. B minus 0, x2 minus 0. So you get x2 by 2. But here, AB means B minus A. B is what? That is x2, y2, z2. A is what? x1, y1, z1. So this minus this. What do you get? x2. Okay, first I'll write this equation. OB equals to AB equals to OB minus OA. That is nothing but vector B minus vector A. Okay? Call this as equation 2. Now we combine these 2 equations. That's it. Okay? Combine these 2 equations. So, and then I will take this triangle. Let us take this one now. OAP. Okay? AOP. Triangle OAP. OAP. So in triangle OAP, I can write. If you want me to put this one, if by combining these two, before that, if you want me to write AP, I can write it as now. Vector AP can be written as lambda times AB is B minus A. B minus A. So let us call all of this as this one instead of having so many things. Let's call this as one. Now I will write triangle AOP. So in this one, I will write again vector AP can be written as sigma. This one, if I consider only this triangle, I will write this is like this. OP minus OA. Vector OP minus OA. I hope they are following this. I wanted this one. So this and this in opposite direction. This OP and this is AOS minus OA. Minus OA. That is, this is vector R. R minus A. This is nothing but vector R minus A. So now, follow this as 2. Now you see, AP, from this it is this one, from this it is this one. Just equate these two. From 1 and 2, you will get vector R minus vector A is equals to lambda times vector B minus vector A. Now we wanted only R. Sign A that side. So it becomes plus A plus lambda times vector B minus vector A. So this is your equation of the line in vector form. I'll just repeat this steps once again. Please, this thing I hope you understood. Whatever is given in the problem and what you need to find. You have to express it diagrammatically and also using symbols. So, okay, all these points very important. Okay, directions also. In vectors, remember, if you don't put the direction, you don't, you lose the marks. You have to show all these directions. Then, here basically, first, what is AP? Three concepts are there. So AP you can express lambda times vector AB. That is one part. Then vector AB you can express in terms of these two things, B minus A. Okay? Vector AB. I'm just putting like this, but you can even avoid this and simply write vector AB is vector B minus vector A. Okay? So you get one equation. The other equation is you take this triangle. In this triangle, you can write AP using R and A. Here AP you are writing using B and A by taking this bigger triangle. The same AP taking smaller triangle you can write in terms of R and A. That is R minus A. R minus A. Now AP you have written in two ways. One is lambda times B minus A. Another is R minus A. Both are equal. AP. So you just equate these two. If you equate these two, you will get R. A you know, B you know, vector. Lambda is some constant. Okay? And if you compare with your previous equation, see here, previous equation is what? Vector A given point plus lambda times your direction ratios, right? Yes, direction ratios of the line. Vector B minus A is nothing but direction ratios of the line. Vector B minus A is the direction ratios of this line. Same thing here. Okay? Only thing is, they are given the direction ratios. Here they are given 2 points. From those 2 points, you can get the direction ratios. That is B minus A. Okay? Difference of 2 vectors. That's it. Now, if you want Cartesian form, okay, you do it. I will give it as a help for you. Cartesian form. Basically, you need to substitute all of these things, okay, into this equation and then simplify. Maybe once this is a vector form of equation. Once you write, maybe I will also do it. People who can do it yourself. This is vector form. This is vector form. Please understand, it will be very difficult if you blindly if you want to remember all of this, it's not possible. So you should draw this diagram. From that, you should be able to write yourself. Okay? What's the time? 5 minutes. So, have you written all of this? Okay. Now, if I want Cartesian form, this is the starting point for us. So, I'll write here Cartesian. Please do it parallel yourself. So, Cartesian form. Same equation in Cartesian form. For Cartesian form, you start with this vector form. All the derivations, this is the sequence that we follow. First, we derive a vector form, then from that we can get vector I equals to vector A plus lambda times vector B minus vector A. So, it is next is actually algebra, vector algebra operations. What are the operations here? Vector B minus A, then addition, then equality. 3 operations. So, R is what? X. I substitute everything in component form. Xi plus yj plus zk is equals to a. It is x1i plus y1j plus z1k plus lambda times, this is vector A. Lambda times vector B. Vector B is x2i plus y2j plus z2k minus vector A. This is one vector A and another vector x1 I plus y1j plus z1k. Now I will try to write less number of steps. Okay, because it's too much if I have to write many steps. One, I can write this entire thing. You see, I write in one step. That is, this is x2 minus x1 for I. Lambda times x2 minus x1. Here it is x1. I components if you see here x1 is there. Here lambda times x2 minus x1. So I can write x1 plus lambda times x2 minus x1. This entire thing is I. This is I. I can construct this. This minus this x2 minus x1 times lambda plus x1. This is your I component. I am taking common from all of this. Next, y1 plus lambda times y2 minus y1. This whole j component. J component. That is data plus x1 plus lambda times z1 plus lambda times z2 minus z1 whole theta. So here it is xi. So now x is equated to this one. X equals to x1 plus lambda times x2 minus x1. This is one equation. Another here we use semicolon. Okay, these are all independent things. This equals to this and this equals to this. Okay, here if I write one more step, xi plus yj plus zj. So I am just equating I component here, I component here. J component here, J component here. K coefficient, not component. I should call it as coefficients here. Next, y equals to y1 plus lambda times y2 minus y1. Here, z equals to z1 plus lambda times z2 minus z1. Okay. Now you see, everywhere lambda is there. I keep lambda one side, all other things the other side. x1 if it goes this side, x minus x1, same as earlier thing. Now here you are getting direction there, right? A. But here direction you will get it from this thing, x2 minus x1. x2 minus x1 equals to lambda. But if you want to write, this is lambda. One more step. Here y minus y1 divided by y2 minus y1 is equals to lambda. Z minus z1 divided by z2 minus z1 is equals to lambda. So now you replace this lambda. So all these things must be equal. That is x minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, z minus z1 divided by z2 minus z1. This is the. Do you remember 2-point form in straight line? What is the 2-point form? These two things, right? X minus x1 divided by x2 minus x1, y minus y1 divided by y2 minus y1, right? Because there we have only x and y. Now you will get one more. Z also is there here. Z minus z1 divided by z2 minus z2. Yes or no? The equation of the straight line in 2-point form. If you remember, you had this already. So you will get one more question. So here they may ask only one thing. If they ask Cartesian form, then you have to do both the things. If they ask only vector form, you can stop it on the previous part. So I'll stop here today. If you have any doubts, you can take it up. Online, who are all that students? Can you say hello to me? Lakshmi, Vijay, Snehashri, Ravikant, Spurti, Archit. Oh, Archit. Arpita also there, Archit. Bhavani, Vandana, Prajwal, Kaustubh, Sanjana, Rahul. Okay, Ramprasad. Okay, we'll stop here, students. Any doubts, online students? If you have any doubts, please let me know. Okay, fine.